We're differentiating rational functions, which basically means as we look inside here, we have polynomials going on, something on top, something on the bottom. So it's not just as straightforward. You got to apply it to each term as you do it. So let's remind ourselves the derivative of something on top divided by something on bottom is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, so in this case, that means the top would be our f, the bottom would be our g. And then let's go ahead and I don't want to jump ahead too far. So f prime, we got a lot going on here. I don't want to make any mistakes besides doing too many shortcuts. F prime of x is going to be equal to, derivative of the top would be 4x plus 1. Okay, 2 times 2 is 4. 2 minus 1 is 1. Whenever you have just an x term, it's the number in front. So the number in front's a 1. Derivative of a constant is 0. Derivative of the bottom with respect to x, just the 2. Like I said, when you just have an x term, it's the number in front or the coefficient. And the derivative of a constant is always 0. Okay, so now we just put all of this into this formula. So that implies derivative of the top is 4x plus 1. We need parentheses. Times g, the bottom, is 2x plus 7 minus derivative of the bottom is 2 times the top is 2x squared plus x minus 3 all over the bottom squared, which is 2x plus 7, and all of that would be squared. Okay, yikes. Oh, it's been a while. So I'm basically what I'm looking for here now is simplifying. Is there a 2x plus 7 that I can cancel out? Well, I see there's a 2x plus 7 here, but in this one, is there a 2x plus 7 in there? Well, we got to do it the old, I don't know, the old-fashioned way is the right way of saying it, but usually I have my own method, but let's try the box method. So if I remember right, the x squared goes in the top left. The constant goes in the bottom. I'm trying to factor here. Okay, so then I'd multiply these two together, and I'm going to do a diamond problem. So I'm looking for what numbers multiply. I multiply these two together, and I get negative 6x squared. And they have to add to be the middle number. So it'd have to add to be 1x. Okay, so what two numbers multiply to be negative 6x squared and add to be 1x? That would be 3x and negative 2x. 3x times negative 2x is negative 6x squared. 3x times 3x plus negative 2x is 1x. Good. So these are the numbers that go in here. And then we fill in these spots. Okay. Look for common terms. There's a common term of 2x here. Common term of 3. So 2x times what is 2x squared? And then just confirm x times 3 is 3x, check. 2x times what is negative 2x? Negative 1, and confirm, does negative 1 times 3 make negative 3? Yes, it does. So that means that all of this factored into so now I'm just rewriting this, 4x plus 1, 2x plus 7, minus 2 times 2x plus 3 times x minus 1 all over 2x plus 7 quantity squared. Yuck. All right. But basically what I was doing here is I was seeing if there's another 2x plus 7 inside of here. And that I do have the option of multiplying that 2 through. But no, it is not a 2x plus 7. So there's no way that this will simplify anymore. We definitely could multiply all of this out and combine like terms, but that's not going to get us anywhere because we can already see there's not a common 2x plus 7 here. So that's going to be our final answer either way. I'll go ahead and use this one because I think that's probably more of like what they're looking for, right? The factoring was just to check my work if there was any other options. So let's see how we did. Oh, it's a lot of work here. All right, 4, parenthesis, 4x plus 1 plus 1 in parenthesis times 2x plus 7 minus 2 parenthesis. Sure, maybe I'll go ahead and use this one down here. I don't know. I'll do this like I wanted. I don't like doing that square. So I'm not going to let that stop me though, I guess. 2x squared plus x minus 3, and all of this divided by, all right, how are we going to do it? Okay, so I had to cut it and then do this. One of my students taught me that you have to click this first to do divide. So thank you. I think it was Alex that showed me. Thank you, Alex, on that one. All right, and the bottom is parenthesis 2x plus 7. All of that gets squared. All right. Now, just for logic, one of the reasons why I did decide to do this one instead of the fully factored form is I'm pretty sure I did my work right. But if I made a mistake with the factoring and this was right, then that would be a real shame. I did all this work and I got it right just to put in the wrong answer when I could have put in one that was previously correct. So as a bit of advice, I would do the answer that's complete and that's the soonest one, right? Oh, excuse me. All right, let's see how we did. Nice work. Got it. Oh, really long on taking care of this, right? All right, looks like the same exact style. Oh, we got plugging in numbers. All right, so let's go ahead and do that. Our derivative, f over g d dx, is going to be equal to the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right. You'll get used to it, I know. That's the more you practice, the more you'll get used to it. That means the top is our f. The bottom I'll call h because they already have a g. I don't like to call things multiple letters, right? So let's also go ahead and find out what f prime is. F prime is going to be the derivative of 2x is 2. Derivative of 5 is 0. And what's the derivative of, stuck on g. What's the derivative of h? Derivative of the bottom. 2 goes out in front. 2x. 2 minus 1 is 1. Check. Derivative of negative 3 is 0. All right, so now I just plug everything in to my formula here. The derivative of the top is 2 times the bottom is x squared minus 3 minus derivative of the bottom is 2x times the top is 2x plus 5 all over the bottom squared, x squared minus 3 quantity squared. All right. So the only way that this could reduce at all is if we had a x squared minus 3 inside of here. So if I distributed this, that would be a 4x squared plus, I'm not doing the minus, just the 2x, plus 10x. Nope. Nope, no way. So this is our final answer. And then we can, well, it probably would have been quicker. We're evaluating at -2. If I would have just plugged in -2 into each of these components, so that's one way you definitely can do it, is if you plug in -2 into F, find that answer, plug in -2 into H, find that answer, plug in -2 to F prime, has to be 2, plug in -2 in for H prime, which would be 4, and then you can just plug those pieces in. That would probably be a lot easier than the method I'm going to do, which is, since I've already done all this work, do I want to do that? So I can plug in -2 now and then simplify, and I think that's what I'm going to do. So that's the other way of doing it. So this is the long way. This is the hard way. So, but that's fine. At least showing some multiple methods here. We're talking about it. All right, so now we're doing G prime of -2. So wherever I see an X, I plug a -2 in. Here we go. 2 times -2 quantity squared minus 3 minus 2 times -2 times 2 -2 plus 5 all over -2 squared minus 3 quantity squared. Yuck. Oh. So simplifying. Sorry about this. This is definitely the hard way of doing it. All right, so this turns into 4. This turns into plus 4. That turns into -4. Turns into 4. Okay. Then I would have, so this is definitely a hard way. It'd be much better to plug it into the pieces and then just piece it out, kind of like the table problems we've been doing. But I went this far. Let's go ahead and just do it this way. 4 minus 3 is 1. So it's easy to make a mistake on this. That's why. Plus 4. -4 plus 5 is 1. All over. 4 minus 3 is 1. And it's getting squared. So that's 2 plus 4 over 1. Don't need it. Not too bad, but bad enough. Easy to make a mistake at somewhere along this. So my point is, what we should have done is we should have evaluated what each of these are at -2. So that would have been a lot easier if I took that and made that into -2 into this would be -4. So that turns into 1. -2 into this turns into 1. And then that doesn't matter. Plugging next in, it'll be 2. Then H prime, when I plug -2 in, would give us -4. And then it'd been a lot easier just to, let's go ahead and just look at it the other way, is F prime at -2 is 2 times G, the bottom at 2 is 1 minus derivative of the top, derivative of the bottom. Derivative of the bottom was my H, so that was -4. And times the top turned into 1 all over the bottom squared. The bottom was 1 squared, so what does this turn into? 2 plus 4. There's our 6 again. So notice how much easier it was to do it in pieces, and you don't got to worry about all this craziness going on. All right, so point is, plug your numbers in as soon as you can so that you can use the pieces instead of going through the algebra that we would. And luckily I didn't try factoring and all that. That would have been way, I mean, it would have worked, but it just takes you down the long trail. All right, and this one looks like ones that we've seen already.